blockchain seems like a database because in fact it is, but there are many differences between it and a traditional database.
So what makes blockchain different? Blockchains are decentralized, they are append-only, and inherently in their structure, blockchains are trustworthy. So decentralization is really at the core of blockchain technology. Any data that's added to the blockchain is not managed by any centralized authority, but is instead managed by the participants of that blockchain network. Blockchains are also append-only, or an immutable record, essentially meaning that they're non-tamperable. Any data that's inserted within the blockchain itself cannot be updated or deleted. Any changes are appended to the end of the blockchain. And finally, blockchains are trustworthy in their structure. In a sense, blockchain helps to automate trust between business partners. So why blockchain? Why now? It's automating trust between those business partners. It's bringing together three concepts that have existed: that of ledgers, which allow for full traceability, cryptography, again, which is like a digital fingerprint, and that of decentralization, which helps to eliminate any single point of failure in your business.
So when I send you an email with an attachment of a PowerPoint or a Word document, I'm sending you a copy, right? I'm not sending you the original. You can send as many copies as you want. But if I'm sending you money, I better make sure that I can't just send copies of that everywhere. I need to make sure that I still, that it's not spent in multiple places at once. That's called the double spend problem. So I can't send my $100 to you and save that $100, that same $100 to you, and that same $100 to you. So double spend problem is part of the key of blockchain and how it eliminates that problem.
So today, we rely on big intermediaries, think banks, government, large social media companies, credit card companies, and so on, to help establish trust in our economy. These trusted intermediaries help to facilitate transactions, resolve conflict, and they do a pretty good job of that. But they also do introduce costs, complexity, and time lags. To begin with, these same intermediaries are centralized, and they are being hacked and increasingly are. Here's the thing: these same intermediaries are excluding billions of people from the global economy. For example, anyone that doesn't have enough money or earns enough income to have their own bank accounts, they cost us time and slow things down. It can take seconds for an email to go around the world, but it can take days or up to weeks for money to move across the city. Similarly, they take a big piece of the action, upwards of 10 to 20%, just to send money across borders. They capture our data, and that means we can't monetize it or use it to better manage our lives. And on top of that, our privacy is being undermined.
So think of blockchain really as kind of like checks and balances. Think about it in terms of an exponential leap forward in eliminating fraud, waste, and abuse. What if we could send money and without using these intermediaries anymore? Now, when you think about it, the need for this was really highlighted in 2008 when we had the financial systems crash, right? The financial industry crash. That certainly highlighted the need that these trusted intermediaries, maybe we needed to have some other plan B in place. So there was an anonymous person or persons named Satoshi Nakamoto. You may have heard about it, anonymous. We still don't know who this person is, who published a paper with a protocol for digital cash. And that became the basis for Bitcoin, which is built on blockchain.
Bitcoin is simply the first application built on blockchain technology, just as email is an application of the internet. More broadly, it's a digital cash or cryptocurrency. It's not controlled by a nation, and that's what's of greater interest. But the real big idea here and the value is the underlying technology, and that's honestly blockchain. So people everywhere can trust each other, transact peer-to-peer without any middlemen. And trust is established not by some big institution, but instead by cryptography, collaboration, and some clever code. Trust is native to the technology.
So again, tough to grasp, but we're going to make it real for you. We're going to use the supply chain industry for drugs as our example. And when you think of supply chain in a beautiful world, in a dreamlike world, you have all these external parties who are balancing supply and demand harmoniously. But the reality is always very different than that. It's very costly, a lot of errors and duplication of information, et cetera. And there's this difficulty with this very real issue around traceability from, production to consumption. And when you think about drugs, that's incredibly important to know. Where these drugs originate from? Now you may think, well, what's the big deal with that problem? Is this really a big problem? Well, actually, it is. I see some heads nodding. It's a huge problem. I was actually shocked by the number, but approximately 1 million people die every year from counterfeit drugs. I'll pause on that a second. That's shocking. 1 million people every year die because of counterfeit drugs. And it also is a loss of over $200 billion for the pharmacy industry itself. And if you think that's just a problem in developing countries, think again, because 25% of doctors that were surveyed in the UK said that they had to treat a patient who had gotten a counterfeit drug via the internet and had an adverse reaction to that. So this is a serious problem all over the world.
Right, so before pharmaceuticals actually reach the patient, there's 3 overarching steps, from manufacturer to wholesaler, and from wholesaler to pharmacy or hospital, which often plan and manage their data in complete isolation. While the impact of big pharma is clear, there are also implications to the public health sector in terms of safety, customs search and seizure, as well as the FDA shutting down of illegal online pharmacies, as Marian mentioned. Less tragic, but equally real, are the financial consequences. So along with losing that 200+ billion annually in lost sales, these same pharmaceutical companies are spending any money on marginally effective anti-counterfeiting measures. Eli Lilly, for example, spent just over $100 million over the course of the past year to thwart counterfeiting of their big name remedies. Sales lost to fraudsters and money spent to combat them means less money to spend on research and development, and puts pressure on cutting costs in other areas, such as headcount. One cost that's even harder to quantify here is any of the reputational cost that's lost.
Right. So why is blockchain a solution for any of this? So the traceability thing is absolutely huge. I think we've put together a business case around that one. And we'll talk about how that works, and you'll see it in your activity. Also, you know, these centralized databases are big targets for hackers. Blockchains, not so much. It reduced costs. We'll talk about that in just a couple minutes. And then, really, you don't have to change your supply chain at all to implement it. So when we were putting together this exercise, we were thinking, how can we make the concepts of blockchain like tangible? They're pretty abstract. So we wanted to find a way to make it real for you guys. And so you guys are going to be our supply chain. And we kept it super simple, right? A real supply chain is got arrows flying everywhere and all kinds of boxes every place. We decided let's just streamline it down to get the ideas. So our participants in this exercise in the supply chain is manufacturer, wholesaler, pharmacy, and patient. And if you take a look on your tables, you should have clipped together some bags. Why don't you unclip them, and 3 people, 1 each bag. Take them for me, and these bags represent these different manufacturers. Let me walk through that, pass them around. So let's take a look at what we've got for you here, what we're trying to represent. So this is a pharmacy, and on it we have a symbol for a database. And the concept we're trying to get to you here is that each one of these players have their own independent database that nobody else can see. You can't see into this. You don't know if my data is real or bad or screwed up or whatever's going on in here. You can't see it. So now let's just, you guys who have the bags, just take a peek. Don't pull anything out yet. Just open it up. And you should see some little slips of paper. Those are bits of data, and we're going to have you guys put them on a blockchain in just a second. But again, the key concept for step 1 is to say we have databases, and again, very simple, because we all know in an organization there's more than one database, right? And they're very hard to sync up within one organization, let alone between organizations, right? That's a huge, huge issue. So lack of transparency, we don't know what's in here, therefore we can't trust it. It's called untrusted.
Go ahead and remove those cards from your bag. Just lay them out in front of you. And on the board, those of you that aren't one of the participants, you can see what each manufacturer, wholesaler, and pharmacy has in their bags. So in order to support the supply chain participants as they move through the supply chain, and in order to adhere to track and trace regulations, these are the data elements that each one of these participants manages, maintains, and ensures is accurate and in sync between one another. You'll notice that the first 4 data elements, which the manufacturer is responsible for, is duplicated by not only the wholesaler, but also the pharmacist. So the wholesaler and the pharmacist is responsible for maintaining a record of, okay, what batch of pharmaceuticals did I procure is in my distribution channels, And for the pharmacy, same thing. Essentially, what prescriptions am I filling? What batches are those a part of? Are any of those expirations out of date or past due? So those first 4 data elements are duplicated, and as you notice there, we'll move forward. Any area that is represented between the blockchains here actually represents where counterfeiting or fraud tends to happen. So in the case that Marian mentioned with counterfeit pharmaceuticals, what has happened is basically fraudsters or counterfeiters have taken photos of these data elements here and have inserted fraudulent packaging and pharmaceuticals that don't adhere to or use the same ingredients that you would imagine a brand name drug to be using. So what would it look like if our pharmaceutical supply chain was on the blockchain? On each table, we have 3 blue squares here, and at the bottom of the slide, you see the same. These will represent blocks in our blockchain. So as a manufacturer and these participants in our supply chain, a manufacturer would move their data elements, so manufacturers at each table, move your 4 cards to that first block there. You no longer need to maintain this in your own database. Instead, all of these participants in the supply chain can now view the data elements that you've added and committed to the blockchain, such as the serial number, again, batch, expiration date, who you are as the manufacturer. You don't need to maintain that. Wholesalers, the same goes for you. Because you can reference the blockchain, any activity that's happened on the blockchain, you no longer have to maintain that in your own siloed database any longer. So go ahead and put those cards to the side. Instead, to facilitate the blockchain, you'd append your record as who you are as the wholesaler. The same goes for the pharmacist. So the pharmacist no longer needs to maintain those data elements any longer, but as part of track and trace, they also had a record of who their wholesalers are. So because they can view the blockchain and they're a participant of this network, they no longer need to maintain that in their own database and instead can reference the blockchain. So put aside any wholesaler card or data element that you may have and only append the data that's relevant to who you are as the participant. So prescriptions that you're filling, maybe any anonymous patient information, you'd append to the blockchain here. But how are these blocks linked together? You may notice that each one of your tables, there's another element that's described there, which is a reference to the next owner and the previous owner. So these blocks are chained together, hence the term blockchain, by a reference of the previous owner and next owner that's created through cryptography, again, like a digital fingerprint. Any changes that need to occur to the blockchain wouldn't happen in between these linkages, but instead would be appended to the end of the blockchain.
So we've gone from hoarding our information and nobody knows what we've gotten to putting it out there so it's transparent, and we can see now what everybody has and we all agree on it. So that's that transparency element. So those of you who don't have bags, you think you're off the hook? No. We've got something for you to do too, because at a high level, these assets, whether it's money or music or whatever, they are stored. You've got them on the blockchain, but where do these blockchains reside? Are they all in one place? No, they're not. They're actually distributed across millions of computers. So we are we have the concept of distributed and decentralized and consensus, and that's what we're going to hit right now. So if you look underneath your blockchain that you just made, go ahead and look underneath it. There's copies of of your blockchain. Take one and pass it around. We're distributing it. We're decentralizing it. All right, now I want you to look at your neighbors and look at your own and see, are they all the same? Are there any differences? You're checking right now. This is what happens in the blockchain. It checks to see if there's anything going on, if they're all the same. Are all of yours the same? Thumbs up if they're all the same. Thumbs up? Thumbs up?
It's the first.
Looking good. All right. Let's just say there are some nefarious actors in here who's going to try to counterfeit something. Nefarious actor 1, nefarious actor 2. Bad actor. Go ahead, do what you're supposed to do. Try to mess them up. All right, so they are trying to kill you with bad drugs. All right, so look around. Is there something? Are these all the same now? Yes? Thumbs up or no? Thumbs down. All right, thumbs down. All right, very good. So what we've just done is gone through the concept of decentralized and distributed, and then consensus. You're all checking against each other. This is actually part of the security of it, is that there's this constant checking going on, and if somebody tries to mess with it, everyone goes, hey, that's not right, and flags it and rejects it. So that's how that works.
So the miners in a blockchain network essentially provide decentralized security to the blockchain. So not young people or hackers. These are groups of miners that actually have 10 to 100 times of the compute power of Facebook, LinkedIn, Twitter, all combined. These miners do a lot of work, and every 10 minutes, like the heartbeat of a network, they validate the transactions that occurred in that prior 10 minutes. And the most important part here, again, those linkages that you see between the blockchain, whenever a block is confirmed and validated, that those blocks are linked together with that cryptographic hash of the previous and the next owner.
Number one, previously, without a blockchain, all the parties in the supply chain, you don't know what they've got, right? There's no transparency. I need to check everything because I don't know what you have in your database. So I need to check. Then we said, okay, wait a minute. What if we have a lot of common data? Why are we duplicating it all the time? Let's get it out on the blockchain and add to it, and now it's transparent, and we can make sure that we all have the same data. And then we distributed it. It's distributed and decentralized, and we had you guys check each other. And that's part of the automation of trust. We're checking all the time. If somebody tries to mess it up, everybody goes, wait a minute, flags it, and rejects it. So that's how that works.
So if I wanted to go back again and say hack or alter blocks, I would have to change not only the block that I want to change, but all preceding blocks, all of the commerce that has happened on that blockchain, and that's really tough to do so. It's honestly infinitely more secure than computer systems that we have today. Blockchain technology allows you now to interact with one another peer-to-peer without intermediaries, and also eliminating any single point of failure in your business. Decentralization does help to shift power to its users by allowing participants to trust one another, and again, go back throughout the blockchain or ledger and see and verify that transactions are not only valid, but accurate. Blockchains help prevent double spending by making all transactions irreversible.
So this is another key distinction between a blockchain and a traditional database, is that with a traditional database, you can just go in and make a change, right? You don't like something, something's wrong, you just go in and make a change. You can't do that with a blockchain. You actually have to append it to the end. So it's immutable, doesn't change. You'll hear those words a lot around blockchain. Immutable means you can't change it. You have to append the change, you have to add the change to the back. The main thing distinguishing a blockchain from a traditional database is that the specific rules about how you put data into the database.
And so that is that the data within the blockchain itself is consistent. It's append only, therefore it's immutable, and that the data itself is actually locked to an owner. A participant in the network, you can, again, read as much as you'd like, but you can only add or update data as an actual member of that particular blockchain. So while blockchain is getting a lot of attention and solves a lot of problems, it's not appropriate for every situation. So the table above helps to compare a public blockchain to private blockchains as well as a central database. We would think of performance across either blockchains or just a traditional database as throughput and latency. A central database is exponentially times more performant right now than blockchains. So blockchains add a layer of complexity through not only the use of cryptography, but also those consensus mechanisms. Some confusion whether or not a blockchain just means that all of your data is widely available to everyone. Public blockchains such as Bitcoin or Ethereum do allow any participants in and out of the network, whereas a private blockchain is a bit more of a centralized solution where there are privileged users and there is a centralized authority determining who can actually participate in that blockchain. Next, we have contributors. So contributors in the blockchain ecosystem are really writers to the database. Those contributors play a crucial role in the consensus and determining whether or not records or transactions are valid in the blockchain. For public blockchains and private blockchains, you may notice that there's a high level of contributors for a public blockchain, whereas there's a low number of contributors in a private blockchain because you do control who is actually able to participate. For a centralized database, however, you would never have any untrusted or unknown parties adding to your data. And so just so you can see the difference between a central database here, the key point that we want to make is that although a central database may be more performant, it does not eliminate the fact that it is a single point of failure. We believe that blockchains are most effective and bring the most value when there's competitors cooperating. Anything else is more of an intranet or a walled garden. So along the left here, we have a startup, a consortium, individual companies and their holding companies. We've arranged is how we see blockchain technology emerging within our clients and within the broader blockchain ecosystem, from most disruptive to an industry to least disruptive there on the far right. So let's start here with a startup. It can be a startup in the most traditional sense, or for you, our attendees, it can be a stealth startup. We're seeing many companies trying to either involve themselves in developer communities, leverage open source technologies to really tackle blockchain as a solution for them. There's also the idea of consortiums. Blockchains essentially enable this world of coopetition, essentially business competitors working together for essentially mutually beneficial results. Next, we have individual companies and holding companies. Believe it or not, your competitors might be under the same roof as you. So think of large conglomerates like a P&G or a Unilever, where they may have to obfuscate or anonymize transactional data between parties, but there are benefits that you can have where you can share that data now anonymously, securely, and only allow those specific privileged parties access to that data. Finally, again, we believe that there is transformational value to explore blockchain technology at the internal company level, but you're poised to really disrupt your industry if you explore blockchain and embrace your competition and collaborate with your competition.
So we talked about the technology and why it's different. We talked about how it could disrupt your industry. And now we need to think about, well, what should we think about? What should you be doing next? So there's three options, basically. You can buy, partner, or build. And if you're thinking of buying, there's some very good blockchain as a service companies, big names like Microsoft and AWS.
You can partner. Again, I mentioned consortiums. Consider partnering with your competition, form a consortium, really try to reach an agreement on shared problems and lay the foundation on how you're going to leverage the technology. I want to mention here that we often see private blockchains as being the solution, but in a private blockchain, one entity really controls that whole system, whereas in a consortium, there's a shared authority and you agree on those rules together. Consensus is managed by that set of participants.
And then finally, you can build. There is a lot of tried and true blockchain technology out there. I know you think it's a new technology. What's tried and true? There really is a lot of history now and work done around these. So it could be something like Bitcoin or Ethereum would be a good place to start. So engage with their communities and see where you can add value.
If you remember nothing else, remember this. Blockchain is here and that you can start today. We're in the national anthem of a 20-inning World Series game. Identify any coordination burdens in your processes that could be working with untrusted parties, process loops. Any lessons learned are worth it.
Blockchain is both evolutionary and revolutionary. So it's evolutionary because when you think about it, there's been this trend going on for quite a while now with the decentralization of computing power. When computers first came on the scene, they were all just in one company and they just worked on that stuff. And then over time, they started connecting with each other through EDI and ERP systems, et cetera. And then there was the internet, further pushing it out. And now blockchain takes it even farther out, decentralization. And it's revolutionary because that evolutionary step can have tremendous impact on how your business functions, as well as really eliminating fraud, waste, and abuse.
And last, proactive or reactive, the choice is yours. There are good arguments to be being reactionary, that is learning from the pioneers, or being proactive and getting ahead of it. Now that you know more about blockchain technology, what it is, why it's important, you're better positioned for the future.